Covering lesson 104. So 104 has two parts. 104.A, which is on arithmetic series. So I wanted to go over the difference between an arithmetic sequence and an arithmetic series. So a arithmetic sequence is when we have a number of terms that have a common difference. And common difference mean I'm either adding or subtracting by the same number. So in this example here, I'm adding 3 each time. So it's a pattern where I'm either adding or subtracting by the same number. And I'm going to go over the formula for an arithmetic sequence because we're going to need it later. And that is A(n), that's any term, equals our first term, A1, plus n minus 1 times our common difference. And so that is the formula for an arithmetic sequence. Now, an arithmetic series is when I am going to add the terms in my sequence. So I am adding terms in a sequence. And I'll go ahead and give you the arithmetic series. So in arithmetic series, I'm looking for the sum of a sequence. And so that formula is the arithmetic series, the sum of the following terms, like the sum of the first 9 terms or the first 11 terms, equals n divided by 2 times the first term plus the term that we're speaking of. So here is the formula for a series. So we're going to do just 2 examples. So the first. So in a lot of these, it's going to tell you information about the sequence, and then it's going to tell you to find the series. So number 1, an arithmetic sequence has a first term of -10 and a common difference of 20. So far, I know that A1, or first term, is -10. So A1 means first term. They've also told me that my common difference is 20. Use the first 4 terms of this sequence to write a series and develop the formula for the sum. Then use the formula to find the sum of the first 11 terms. All right, so first of all, I need to know, I'm going to use the first 4 terms, right? If I know the common difference, then it's going to be super easy to find the terms. So I need to find, in order for me to do this, if I'm going to find the sum of the first 11 terms, it would look like this. The sum of the first 11 terms equals n, which in this case would be 11, over 2 times A1 plus A11. Now, I know what the first term is, it's -10, but I don't know A11, so I have to find A11. So, A11 equals my first term, -10, plus 11 minus 1 times my common difference. So, I'm using this formula here, and I plugged in A1, and I plugged in my common difference of 20. So I apologize, I think my pen's running out. If I simplify this, I get -10 plus 10 times 20. 10 times 20 is 200 minus 10, A11 equals 190. So I now have the information needed to find the sum of the first 11 terms. So the sum of the first 11 terms equals n over 2 times my first term, which was -10, plus my 11th term, which was 190. So I'm plugging in, and I should have, this is n, but so is that right there. Notice n and n is right here. So I plugged in 190 for here. I plugged in the first term, the first term here, and then I plugged in 11 for here. So the sum of the first 11 terms equals 5.5 times 180, so I get 990. So the sum of the first 11 terms equals 990. All right, number 2 is kind of repetitive. It's how to develop the formula. So how to develop the formula for the sum of n terms of an arithmetic series whose first term is a1 and the last term is an. So the sum of n, again, is n over 2 times the first term plus the term that we're speaking of. So it's just the formula written again. All right, using the formula from number 2, find the sum of -2 all the way to 46. So they've told us here's A1 and here is AN. And this should say, do I not have a part B? Sorry, this should say find the sum of the first 9 terms. And sorry about that. It should have said that, and I forgot to type that part up, so I will edit that. Let me make it Post-it, sorry. All right, so I know A1. Now, if I'm looking at these terms, my common difference is a positive 6, right? I'm adding 6 to -2. I'm adding 6 to get 10. So I need to find A9. So I know my first term, A1, plus n minus 1 times d. So I don't know A9, but I do know the first term is -2. And then plus 9 minus 1 times the common difference of 6. So I know that A9 is, I'm going to plug in this. So -2, this is 8 times 6, 48 minus 2 is 46. So beautiful, this is the 9th term. So to find the sum of the first 9 terms, I have to do 9 over 2 times the first term plus the 9th term, which in this case is 46. So 9 over 2 times -2 plus 46, and I get 198. So that is the sum of the first 9 terms. So I apologize. I should have typed this up for number 3. All right, moving on in our notes to 104.B, which is on geometric series. So a geometric series is formed by adding the terms of a geometric sequence, just like an arithmetic series. So an arithmetic series, you're adding the terms of an arithmetic sequence. A geometric series, you're adding the terms of a geometric sequence. So let's go over what a geometric sequence is. A geometric sequence is like -2, 8, -32, +128. In an arithmetic sequence, I am multiplying or dividing by a common ratio. And the formula for an arithmetic sequence, in case you've forgotten, is AN equals A1 times, and now I'm forgetting, times R, I believe, to the n minus 1. See, now I'm forgetting what an arithmetic sequence rule looks like, but I'm pretty positive. Sorry, in a geometric series. Sorry about this. This is a Friday morning. And I didn't put it in my original notes. And beautiful. I'm right. I just started to doubt myself. So this is but we are going to be working on a geometric series, and the formula for that is the sum of so many terms equals our first term times 1 minus r to the n. R is our common ratio, just like d is our common difference, divided by 1 minus r. So there's the formula for the geometric series. So let's try a couple examples using that. Oh, and I didn't realize I left a space for that formula here. Sn equals a1 times 1 minus r to the n divided by 1 minus r. All right, so we are going to develop the formula for the sum of the first n terms in a geometric series and use the formula to find the sum of the first 9 terms in a geometric series whose first term is -8 and whose common ratio is -2. So I know a1 is -8 and I know r is -2. So in order to find the sum of the first 9 terms, I need to know what the 9th term is. So I'm going to find, and maybe, you know what, I actually don't need it for this. I have everything I need. So the sum of the first 9 terms is our first term, which is -8, times 1 minus our common ratio to the n, and in this case, n equals 9, so to the 9th, all over 1 minus our common ratio. So I'm going to simplify the top. This is -8 times 1, sorry, I'm recording, 1 minus, thank you, -2 to the 9th, which is 513, divided by, this becomes positive, right, and I have over 3. And so I get an answer. The sum of the first 9 terms is -1,368. Next one, find the sum of the first 10 terms of the geometric series in example 1. So now I'm finding the sum of the first 10 terms. So the sum of the first 10 terms equals the first term times 1 minus our common ratio to the 10th, all over 1 minus our common ratio. So I know the bottom is 3, and this is -8. I'm going to simplify just this part. So first I'm going to do parentheses, -2 parentheses to the 10th. And so 1 minus 1024 gives me a -1023. But I'm going to be multiplying that by -8 and dividing that by 3. So the sum of the first 10 terms is 2,728. All right, so let's move on now to some more complicated ones and see if hopefully I set this up correct. So I have 3 minus, sorry, let me change my screen, 3 over 2 plus 3 over 4 minus 3 over 8 and so forth. So in an infinite geometric series, I'm going to set this up a little different. So first, I know my first term, right? I know a1 equals 3. And I know that whatever a1, I don't know what r is though. a1 times r, though, gave me the second term of -3 over 2. So I need to find my common ratio. So I know a1 is 3. So 3 times r equals -3 over 2. So if I divide both sides by 3, r would equal -3 over 2 times 1/3. So r equals, these cancel, so -1/2. So my common ratio is -1/2. So I now have at least I have my first term and my common ratio. The second is in an infinite series, I would be set up an infinite. Means it's going to continue on and on and on. So in an infinite series, it should be the sum of n equals the first term divided by 1 minus r. Okay, so I'm going to just put a... So the sum of an infinite series equals my first term, which was 3, divided by 1 minus my common ratio. So this gives me 3 over 1.5, which is 2. So the sum of this infinite series, if I add the first term and all the terms after, if this continued on and on, I would get close to 2. Next one, find the sum of the following geometric series. And because this doesn't ask me a specific number, then I know they're referencing that this is an infinite, because it didn't say the sum of the first 7 terms or the sum of the first 9 terms. So let's identify, I know this is A1, but I don't know R, so I have to find my common ratio. So I do know, though, that my first term times R gave me my second term. So my first term is 1/4 times R gave me -3/16. Right? Divide by 1/4 or multiply both sides by the reciprocal. And I get R equals, this can be reduced, so -3/4. So I now have R. So an infinite series equals my first term divided by 1 minus my common ratio. So that gives me 1/4 divided by, this becomes positive, 3/4, which is 1/4 times 4 over 3. So I get 1/3. Let me make sure I did that right. Sorry, this should be right. I'm looking at that. That's not right. This becomes 4 over 4 plus 3/4. That's 7/4. So if I flip that over, that becomes 4 over 7. So my answer, these cancel, is 1/7. Whew, that is a lot. Homework 104. You're going to skip number 2, 4, and let me confirm with the book. I will enter that into Canvas because I need to confirm the problems that we are skipping. Thank you.